right. Good morning, everyone. How's everyone doing? Having a good re:Invent so far? Thanks for joining us this morning. We're going to spend the next hour going over a use case very specifically to Amazon DynamoDB. And we're going to talk about Oath's experience building a multi-region GDPR application. And so GDPR, for those who aren't familiar with GDPR, it stands for Global Data Protection Regulation. It was approved by the EU Parliament in 2016, and it went into effect earlier this year. So one of the things I think is important to say is the focus of this conversation is not necessarily the regulatory requirements around GDPR. It's actually really about the underlying technology and the technology around building that application. So my name is John McCammon. I'm a Senior Solutions Delivery Manager with AWS. I'm joined today by Sunil Joshi, an AWS Technical Account Manager, and Mika Minerma, Oath Vice President. So our agenda today, we're going to go through a brief overview of Amazon DynamoDB, discuss very specifically DynamoDB global tables, and then jump into the use case for building the multi-master replication for Oath's GDPR application. So cloud application characteristics are very different from traditional applications. And so users can be in the millions. We're talking about exabytes, petabytes, exabytes of storage, performance expectations and needs in the milliseconds and microseconds, and requests in the millions, or on a busy day can be tens of millions of requests per second. And these applications have the need to scale up, scale down to meet the user demand, and also to be able to maintain alignment to the right cost profile. Developers need access to APIs, and more specifically, managed APIs. The growth of internet-scale web applications, such as e-commerce or social media, the explosion of connected devices, such as phones, tablets, and big data have really resulted in new workloads. And these workloads are different today than they have been traditionally. So these new workloads, often the traditional workloads rather, used relational databases. The new workloads are often not suited well for relational databases. And so scaling relational databases to handle concurrency while maintaining strong consistency requires upgrading to more powerful and often proprietary hardware. And this is called scaling up or vertical scaling, and it usually carries an extremely high cost. NoSQL databases like Amazon DynamoDB address the scaling and performance challenges found in relational databases. NoSQL databases trade some of the query capabilities and ACID properties found in relational databases for more flexible data models that can really scale horizontally. So it's a completely different model. And these characteristics make NoSQL databases an excellent choice for situations where use of relational databases for non-relational workloads really result in some combination of performance bottlenecks or operational complexity or rising costs. So DynamoDB offers solutions to all of these problems and is an excellent platform for migrating from those workloads from relational databases. So Amazon DynamoDB is a fully managed NoSQL database service running in the AWS cloud. And the complexity of running a massively scalable, distributed NoSQL database is managed by the service itself. This allows software developers to focus on building applications rather than managing infrastructure. NoSQL databases are designed for scale, but their architecture is sophisticated. And this can lead to significant operational overhead and running large NoSQL clusters. Instead of having to become experts at advanced distributed computing concepts, developers need only to learn DynamoDB's straightforward API, using SDK and the SDK for the programming language of choice. So in addition to being easy to use, DynamoDB is also cost effective. And with DynamoDB, you pay for the storage you're consuming, and you also, that includes the I/O throughput that you provisioned to DynamoDB. It's designed to scale elastically, and while more importantly, maintaining high performance. So when the storage and throughput required of an application are low, you provision what you actually need to the DynamoDB service. As the users grow and as the performance requirements increase, you can, on the fly, provision more resources to DynamoDB. This enables an application to seamlessly grow to support millions of users, thousands of concurrent requests to the database per second. And then finally, of course, DynamoDB is secure. There's support for encryption, end-to-end encryption, and fine-grained access control. So with that, it's just a brief overview of DynamoDB and some of the key features and where it may be used, as I mentioned, for web scale, really using the right tool for the right job, right? We'd like to transition into a little bit more detail about DynamoDB global tables. So with that, I'd like to introduce Sunil, and he'll come up and dive into global tables.
Thanks, John. So global tables builds on Amazon DynamoDB's global footprint to provide you a fully managed multi-region, multi-master database. Global tables replicates your DynamoDB tables across AWS regions of your choice. Customers make that choice based on the needs of their applications and the locations of their end users. A global table looks just like a DynamoDB table with the same data model and the same API. Your applications control which region to read and write data to using existing DynamoDB endpoints. Then under the covers, global tables does the difficult task of replicating data and resolving update conflicts. This enables you to focus on your application's business logic. Global tables enables your applications to stay highly available even in the unlikely event of isolation or degradation of an entire region. And finally, global tables enables fast local read-write performance for massively scaled global applications. Now let's look a little deeper into how multi-master replication enables low latency local performance. In this diagram, I've got 3 replicas of a global table in different regions. And there are applications running in each of these regions. The applications are doing pure local reads and writes to their own regions. You get the same single-digit millisecond response time that you typically get in DynamoDB table today. And this is because there is no new code to write, and you are going straight through to the tables using existing endpoints. When you do put in a region, the system comes back and says that your put was done locally. Then we figure out that we need to replicate this data across all the regions. Now, there are two caveats that you have to watch out for. One is this data is replicated asynchronously. Therefore, your local reads are eventually consistent. And second, you may get update conflicts. Now, global tables resolves these conflicts deterministically using last writer wins policy. So with this policy, the replications complete typically in 1 or 2 seconds in most cases. Now, there are some applications that can tolerate these eventual consistent reads or the update conflict resolution policy. Take, for example, user profile data that can only be updated by a user, and the users are predominantly local. Secondly, there are global applications that do read-only transactions and require low latency performance. For such use cases, global table solution is ideal. And we are going to talk about just such an application in this customer case study. But before I do that, let me do a quick introduction of our customer, Oath. Oath is a subsidiary of Verizon, and it is committed to building brands that people love. It was formed last year with Verizon's merger of AOL and Yahoo. Oath is now a dynamic house of media and technology brands, including Engadget, Huffington Post, Verizon Digital Media Services, Yahoo Mail, and many others. Some of them are on this page. The scale of Oath is massive. It connects with more than 1 billion people around the world. It reaches more than 2 billion mobile devices. And it leverages more than 4 trillion data points every month. Oath and its former AOL and Yahoo entities have had a long-standing relationship with AWS. AWS is home to many of Oath's marquee web properties. And Oath runs key segments of its programmatic advertising business on AWS. And just this past May, we announced that AWS is Oath's preferred public cloud provider. Most recently, and that's what we are going to talk more about, is that Oath needed to become GDPR compliant. And then Oath looked to AWS to help get its job done. For context, GDPR, also known as General Data Protection Regulation, is a new privacy law in Europe that went into effect May 24th of this year. It's a set of requirements that applies to all organizations that process personal data of EU residents. It does not matter where the organization's location or industry. It is ultimately designed to give the people of Europe more protection and control over their data. So instead of focusing only on EU residents, Oath proactively took the initiative to go a step further and take a global approach to compliance. So that idea was to have the data trusted and protected across all markets. Enter Amazon DynamoDB Global Tables. We worked with Oath to ensure that global table service was available in all requested regions before the GDPR deadline. And I'm happy to announce that the OAuth content, which reaches more than 1 billion people around the world and more than 2 billion mobile devices, was GDPR compliant and on deadline. And here to talk more about this story is VP Architect from OAuth, Mika Manerma.
Thank you. So let's talk about a little bit about GDPR and the integration of that of AOL and Yahoo and how it affected the case what we were doing and how we actually use the global tables to store our privacy control data. First, a little background. So as you heard, that we were formed a little bit over a year ago. So OAuth, nowadays also known as a Verizon Media Group, we needed to first tackle how do we manage our privacy for our users. How do we get all the users under the same umbrella and under the same controls? So this was not only about EU users, this was also about global users that we have, and all the users of Yahoo, AOL, Engadget, Huffington Post, Riot, and countless other brands. They need to be brought under the same umbrella and under the same controls. So this was the first major driver. Of course, the GDPR is the second major driver of this. The deadline was looming, and we had to address these both events simultaneously. So, and we wanted to have these privacy controls, these strengthened privacy controls, to have them available for everyone, not only for European users, but for everyone. So there were many other requirements and services that we need to build for GDPR, but we will in this session only concentrate on our privacy control service and how we build it. And of course, while you are planning all this kind of a massive event, there's going to be some challenges and requirements. And when you have a massive scale of more than 1 billion users, things might not be that simple always, even though you think they are. So the GDPR and the updated terms of service notification is an inherently a one-time event where we basically ask from every user that, okay, here is new terms of service or new privacy policy, do you accept them, and also present the privacy controls, etc. There's some difference between European users and global users. In Europe, you have to follow the GDPR regulation to the letter, and there's a slightly little different version for the European users. But in practice, all the controls are the same. So in Europe, before you can use any of OAuth services, you have to go through this service. You can imagine that how critical this service is. You can't access any OAuth service without going through this service first. So if the service is down, you can't access. So this criticality of the service made that we had to have a very hard look on availability and performance requirements. And for our global users, they still needed to be shown the terms of service, the updated terms of service and privacy policy for a period of time. And in addition to having this shown to the users, we also needed to actually enforce the privacy controls in every single service that we have in our ecosystem. So all the services that we have in OAuth needed access to this privacy control data. They needed to access it anywhere where they might be hosted. And we are a major company, so we have services hosted almost everywhere where you can imagine. And not only they need to be able to access it, but they need to be able to access it as fast as possible. So the latency is very, very important. You can't add milliseconds to the user's journey without them noticing it. All this can be a challenge when our services are not even hosted in the same data centers, nor are they always addressing the same region. We have services which are, sorry about that. We have services which are running only in US data centers and serving the whole world. We have also services for example, in Asia, which are serving only Asian region. These services are only meant for Asia region. We have services that are running 5, 6, 7 data centers across the globe, and they are serving all the users in the world. And we have everything in between. We have all kind of situations. So efforts of this size are already a challenge on their own, but when you add the pressure of the May 25th deadline on the GDPR when it went live, so May 24th is when you have to be ready. May 25th was when the law went to effect. So this deadline will not budge, no matter how hard you try to negotiate with the regulators or with your lawyers. Doesn't change. So we set out to build a privacy control service, which will be available globally for all our users. It's localized to many languages. It's, branding is for every single brand that we have. It's serving all our top-level domains in the web, 123 of them, quite many. And we had a lot of mobile applications. We have a lot of desktop applications. On top of that, we have technology in connected televisions. We have other devices that we need to serve as well. All these need to be GDPR compliant. And also, we need to update the privacy policies and terms of service in those services as well. There's a couple of screenshots. You may have seen this flow when you access any of our service, be it the TechCrunch or Tumblr or Riot or anything else. These actually are from Europe, I think. There was a slightly different version in US. Now that you have a little bit of a background, let's take a deeper look into the architecture and actually see that, okay, how we solved this, how we built this to match these requirements that we just went through. So first, let's take a look at the global deployment. So we needed to have this service hosted close to our own data centers and also close to our own services that are running in some of the regions. So this picture is an illustrative. It's not the actual deployment, but to just give you an idea. It has the 4 data centers of 4 AWS regions where we put this privacy control service. Right here, over here, and here. So we have in US West, US East, EU West, and Asia Pacific Southeast regions. These regions were chosen because they were geographically distributed, and they were close enough for our own data services. And these 4 regions also provided us enough redundancy for availability purposes. So let's take a deeper look in one of these regions. All these regions are identical. So this is the architecture. It's very simple. Simplicity is usually best when you are dealing with scale. So when the users want to visit any of the old products, or they want to go to the privacy dashboard where they can manage their privacy controls, or they go to any of these industry self-regulatory portals, they actually get redirected to the closest region where we have the privacy control service. This is just a normal 302 HTTP redirection, and they hit basically privacy control service, which is here. It's a very simple Java-based service. It's running in an EC2 instance. It's running in an auto-scaling group across multiple availability zones. It's fronted by a network load balancer, NLB, and we do the TLS termination in the server itself. The service will provide basically web user interface for the users, and it will provide also a REST API for the connected devices and mobile applications. In addition to that, it provides a REST API for our old products that they can query real-time the privacy control data. This is protected by mutual TLS. And to increase the security and to manage the TLS certificates, we use Athens. Athens is a remarkable solution We have just recently open sourced it, and you can find it in GitHub. It integrates very well with the AWS infrastructure. It leverages the EC2 instance profiles to determine which instance is allowed to have which service identity, and it will provision the TLS client certificate for it. It also works on containers, Lambda functions, and other containers. You can find it in GitHub if you are interested. So you can see in the privacy control service, we have here an Amazon DynamoDB table. This table here is meant for session data. So we have temporary session data while the user is in the user flow, which we need to store about the user. This table is not in global tables. This is partitioned to a specific region. So each region has its own session table, which is independent of the other regions. If a user switches regions during a session, the session needs to be accessed across region. So the session data is always read and written from the original region where the session was created. We needed this table to be extremely consistent, and we couldn't tolerate any replication delay on this table. So we chose this table to be done with the cross-region access. The actual privacy control data here is done with the global tables. So we needed to this data be distributed full data set into every single region. And in addition to the REST API that the OAuth products can access, we also needed to make the data available as a data snapshots for our grid processing, and also we needed to make available as a change notifications to some of the services. So, for example, some of the services needed to be able to get change notifications as they maintain their own cached copy of the data, or they need to do some cleanup if a user toggles their privacy controls. And for the grid data, we have a lot of batch processing, which basically, and they need to be able to process that the batch and know every single user's specific purpose or their control, whether they can use it or not. So before we settled on global tables, we had also other options. So one of the options was to use just DynamoDB tables and do our own replication system. That was actually the first thing that we considered before global tables was announced. And another option was that we actually have our own data centers and we have our own technology which we can use to replicate. However, because the size of this event and it's going to be basically a very temporary capacity with what we needed, it would have required us to build a lot of capacity in our data centers, and it would be temporary. If you don't kind of like have usage for that capacity later, it's not very economical. So this is a perfect use case for a public cloud. And as I mentioned, we needed a very fast access, read access to that privacy control data, and from every single region. We needed to have multi-master synchronization. So we needed to have the full data set there, no kind of exceptions, that's it. So multi-master synchronization is not a very nice problem to solve. We have done it multiple times. There's always a lot of edge cases. There's a lot when servers go down or processes go down, and when to act rights, when to retry them and others. We didn't really want to spend any time on this. So luckily, when DynamoDB announced the global tables availability, the decision was very easy to go with it. So these were our original challenges: elasticity, availability, and time to market. And basically, DynamoDB solved all of these. For elasticity, we could scale up and down, no problems. We didn't need to buy any hardware for this. The full dataset is available in all the regions. So we have redundancy, we have low latency. Time to market was very fast, less than a month, to actually get this operational. And as a bonus, DynamoDB Global Tables is just normal DynamoDB. So you can leverage every AWS service that you are used to, such as DynamoDB Streams and Lambda, which allows us to publish the real-time changes, or AWS data pipelines and Elastic MapReduce, which allows us to produce the batch snapshots. And this all works as you would expect from a normal DynamoDB tables. So enabling DynamoDB tables is very easy. So first you create the table like we would normally create in each of the regions. Here's a simple example that we did for the Southeast Asia region. It doesn't have everything, but don't forget to set the encryption on, and don't forget to actually set the auto-scaling policies and targets for every single region. Then after that, when you have all the tables created in each of the regions, all you have to do is run a simple command, and you have enabled global tables. We are done. Not very complicated. And because of the replication to all regions, we can run our snapshots and we can run our change feeds in each of the regions. And all the OAuth services can then choose which region they are actually reading those snapshots, or which region they are reading the change notifications. And they can do their own failover scenarios independently. Now you may ask that, okay, was this truly this simple? Nah, well, almost. There are some learnings we had when implementing this service. So first, there's an extra write in the same AWS region where the write originated. This extra write is done to the write AWS metadata. It can be ignored if you are not interested in it. So you can easily filter those events to ignore updates, which only does these metadata fields. Or you can try to do something like deduplication or ID impotent operations. We just chose to ignore these update operations, which only touch the AWS metadata fields. Second, this might throw a trick on you, is that if your users are right on the edge between regions, geographically or latency-wise, and your geographic load balancing, if you use one, it might throw a trick on you. For example, if you have a user living in central US and you are serving from east and west regions, you might flip-flop between requests between these regions, especially if you are using multiple domain names. Like in this service, we used multiple domain names, and the user in the same session was going from one domain to other domain, and there's a high possibility that each DNS query might actually route you into a different AWS region. So you are going to flip-flop. This is a problem if you require very, very strong consistency, and if you can't tolerate the replication delay. So for us, the session table that I mentioned, basically we require to have our read-your-own writes consistency on this, and we solve this by partitioning the session tables. And we put the session identifier to contain the region where the session was created. So the session will always tell us, when we get the session identifier from the user, which region that data is. So we can always do and go and look from the originating region and do a cross-region read or write into that region. The same method can also be used to achieve a single master synchronization, or basically force all your writes to a single master or a single region in the same session. It's very nice if your writes are always as a result of a user interaction, because the user, even if they use multiple devices, very rarely are able to click on two buttons at the same time. So you will very rarely have any write conflicts this way, if you can do that. That's a trick that you can use. So when you create your global tables, at the moment you have to select the regions at the time of the creation. You can't add them later. You can scale up and down, but you can't add new regions to the global tables. I hope that we will soon have some features for that. And DynamoDB Local, that's awesome. It's awesome. Our development team was in love with that. It basically allows you to run DynamoDB locally on your laptop, on your CI/CD pipeline. It has the same API as DynamoDB, etc., and you can use it to integrate your functional tests, etc., put it in the CI/CD, and it also allows that you can run your full service on your development laptop in a debugger, and that's very powerful. And lastly, if you have the value-added service, partner very closely with your AWS team. It's very important. Do your joint architecture reviews, let them know what you are doing during the launches, and invite them to your war rooms. Prepare, especially if you have a spike, you know that you have a spike coming, prepare for it. So how did we do? So on the top here, you can see the consumed read and write capacities of a single region. And in the bottom, you can see the pending replication counts. OK. It's white background, so you can't see my pointer. You can see on the left side, before in April, you can see a very small spike on the orange graph. That's when we did write capacity tests and performance tests, because we didn't know really what kind of a load we would get on the launch date. We had some idea, but it's very difficult to estimate what actually will happen on the launch date of such a major event. We don't know if the users are all coming at the same time, are they a little bit staggered, etc. So we did some performance tests first. So, and to understand how this replication actually works and what kind of delays there is, how much queue there is on the replication counts. We also did some read performance tests. You can see the blue count spiking there, which didn't have any effect on the replication, of course. I can't stress how important it is, but you have to pre-plan for these spike events. So based on this testing, and we still had uncertainty that, OK, how much exact load we have. So we thought best that, OK, we need to pre-provision. We need to pre-provision quite a large capacity prior to the launch, and then move to auto-scaling after the event. Not that we were not confident that the auto-scaling would work, but as this traffic spike was going to be such a huge spike, so we need to be absolutely sure that there would not be problems. And also to get a little bit better understanding, we launched you can see between the two orange spikes, we launched actually in multiple smaller segments and multiple countries prematurely, so that we can have a little bit of more data on how this launch will go. And then on the general launch date, on May, a little bit before the GDPR deadline, you will see a spike, a very big spike on the write capacity. That was what we anticipated. And you can also see that the pending replication count slightly hit us at that point of time. The traffic was overwhelming us even beyond our expectations. But luckily, this was easily and fast solved. We just talked with our AWS folks, and we just increased the capacity. Problem went away, and it has been very steady after that. And as for the read and write latency, that's not very interesting, so I didn't include the chart here because it's very stable. It's what you expect from a local DynamoDB instance, so it's no problem at all. So as a summary, we were able to launch the privacy controls to all our users globally anytime. and the project was an overall success. The elasticity that we required at the launch time and the controls on that worked as we expected. We were very correct on our assumption that this is a one-time event. There might be more one-time events later, and that's why we could easily leverage the public cloud without doing any heavy investments on hardware on our own data centers. Saved a lot of calendar and developer time that we didn't need to solve ourselves. In overall, we were very happy with the results and the Global Tables product. And now I will hand back to John to wrap up.
All right, great. Thank you, Mika. All right. So yeah, just to sort of bring this full circle, hopefully through this use case, you can see a few of the key things that we started out talking about, right? Amazon DynamoDB being the right tool for the right job, providing global availability, security, being very cost effective, and key here, the elasticity also, right? So these are some of the key features. Obviously, this is just one of many, many use cases out there for DynamoDB. This is very specific to global tables, which was absolutely crucial for Oath to be successful for GDPR. So there are multiple other events and sessions, obviously, at reInvent for DynamoDB. Hopefully, you guys have a chance to check those out if you're interested in learning a bit more. Right, there's a lot more information out there, and more specifically, we've got a list here for you. So obviously, you can use the app and check them out. Check out those sessions in the app. But we've listed and collected some of these sessions here, so you can take a quick look. DynamoDB is, as I said, as a NoSQL database, right? It has different behavior than relational databases. And what we're seeing pretty often is that where customers are choosing the right tool for the right job, they're getting all of those benefits that are driving their business forward in a very cost-effective way. So we'd appreciate everybody take the opportunity. Just takes a minute to please rate the session, of course, too. And then you can also follow DynamoDB and get updates periodically as those come out. So thank you guys very much for your time. Hope you enjoy the rest of reInvent. There's a lot of good sessions out there, and have a good day. Thank you.